Okay. Assalamualaikum again. Good morning, class. So today will be our third lecture for biomechanics, ENT 218, NMJ 20203. So for today, we'll move to chapter 3. If you refer to the ebook that I already uploaded in our Google Classroom, then you can find the topic there. Okay. So chapter 3 is kinetic concept for analyzing human motion. Last week, we learned about kinematic concepts for analyzing human motion. But this week, we will learn on kinetic part. Okay, mostly kinetic we deal with force. Apa-apa berkaitan dengan force, then dia akan relate dengan kinetic parameter. So we'll go through some slides that relate to kinetic. Okay. What is mass? Yeah. Okay. What is mass? Mass is quantity of matter composing a body. Mass, Mass is represented by M. So symbol is M. The unit are in kg. Different things, mass and weight. Mass, kg, weight, Newton. So force in Newton. Mass in kg. Mass tu dalam bahasa Melayu apa? Bahasa Melayu kita panggil jisim. Weight in Malay? Berat. Good. Pandai. So mass and weight is different thing, okay? Remember class, if you want to calculate, if the question asks you to calculate force, then the unit must be in Newton. Or if the question wants you to calculate the weight must be in Newton. But mass in kg, Jangan confuse benda tu tau. Okay, then. Okay, kita go to the next slide. Inertia. What is inertia? You have learned in engineering mechanics. So inertia is tendency to resist change in state of motion. It is proportional to mass. No unit for inertia. So a few examples. If you can see on your left top of the slides, a skater has a tendency to continue gliding with constant speed and direction due to inertia. The skater don't have any force pushing him, but it's still gliding with constant speed. Why? Because we have an inertia. That is the effect of inertia. There is no forcing force on that skater, but it still glide. Dia masih meneruskan gliding dia because kita ada effect of inertia. Okay, we have another one. So if you can see from this figure also, kenapa dia tak play? Why it doesn't play? Okay, tak apa. Okay, if you can see there is one person on that lorry. So when the lorry hit the rock, that person will be thrown away from that lorry. Why? Why that happened? Because the inertia condition, So although there is no forcing or no force that push the person to throw away from that lorry, but with the scenario of the inertia, then the man on that lorry will be throwing away from that lorry, So that the condition of inertia. And then we have also a force. So this is like just a definition for you. Again, it is just a revision. What is force? We have two type of force: push and pull. Push, pull. Push, tolak. Pull, tarik. The equation, the basic equation for force is force equals to MA. M is the mass. A is the gravitational acceleration. A itu pecutan graviti ya. M is the mass, A is the gravitational acceleration. So the unit for the force is Newton. Sama dengan weight ya. Weight pun sama Newton, force pun sama Newton ya. Both have the same unit of Newton. Free body diagram. We learn in engineering mechanics. If we have some sort of equations, then you need to change all that diagram, the original diagram, into your own free body diagram. So if we have some support reactions, then you need to change it into free body diagram, or we can call it as FBD. Ingat lagi tak FBD, free body diagram? Pernah dengar ke free body diagram? Okay, so we will use a lot of free body diagram in calculation part ya. Okay, and then what is net force, single resultant force. Okay, you have learned in engineering mechanics. And then what is torque? Torque is similar with moment. Torque is the rotary effect of a force. If we deal with rotation of a force, then it is a torque. Or sometimes we call it moment. The equation for torque and moment sama ya, equation dia. Kalau boleh nampak, saya tulis kat sini. So you nampak force. Ya. Yeah, force. Moment equals to force times perpendicular distance. Torque also the same thing. Torque, T, torsion, force times perpendicular distance. So moment and torque use the same equations and the same unit. Newton, D is meter, Newton meter. If the question give you the distance in centimeter or millimeters in unit, then you need to convert that distance into SI unit in meter. Okay, remember? So all the units should be in SI unit. Newton and meter. Okay. So if you can see from that equation, torque equal to force times perpendicular distance, the symbol that symbol is perpendicular distance. So if we can see from that figure, the axis of rotation, the red color, the red color is the axis of rotations. So we have force going down, 10 Newton going down on that bar, then it will rotate clockwise. Okay, it will rotate clockwise. Saya tunjuk Okay, this is the force. So the arrow of the force is going down. Okay, going down. If you can see the blue color, the arrow is going down. So it will rotate to that rotation, to the axis. This is the axis, so it will rotate to that axis. The direction of this force is clockwise. Clockwise, because this is the axis, the red color. So it will rotate to that color, that red color. The rotation is clockwise. Okay, clockwise. Basically, if we deal with moment or torque, clockwise we assume it as negative or positive. Ingat lagi tak? Clockwise, negative or positive? Negative. Okay, good. So this one, the arrow is going down. Force is 10. 10. You can see here 10 Newton. Perpendicular distance here is 2 meter. 2 meter. So 10 times 2, it will be 20 Newton meter. You can also put minus 20 Newton meter. The minus sign state that the rotation is clockwise. If you didn't put any negative sign here, also correct. The negative and positive sign is just showing the direction. Faham Saya tak kata kalau you tak letak negatif tu salah If you put negative, I understand that the direction is clockwise. If you don't put that negative also, doesn't matter with me. Still the value is 20 Newton meter. The negative and positive sign is just the direction of the rotation. Faham If you assume clockwise negative, make sure the other assumption counterclockwise will be positive. If you assume clockwise positive, make sure counterclockwise is negative. Okay, that is based on your assumptions. All right, but mostly we assume that clockwise negative, counterclockwise positif. Biasanya kita assume macam tu. Okay ya. Jangan risau, terlupa letak negatif, jawapan masih betul. Tak salah Okay then. Tengok apa ada lagi. What is center of gravity? Point around which a body weight is equally balanced. Okay, and then point that serve as an index of total body motion. Point at which the weight vector X, and then same as the center of mass. So center of gravity, center of mass is the same thing. If I talk about center of mass, this is also the definition. This is also the theoretical part behind center of mass. Because center of mass and center of gravity is the same thing ya. Ingat, sama tau. Okay, mana lagi? Okay, from this figure, kita tengok Kita ada, we have 20 Newton box on the left hand side, on my left hand side, and I have 10 here, 10 Newton on my right hand side, and then we have a fulcrum over here. Okay, so to make it balance, to make it in equilibrium, we need to design this system like this. Why? Sebab apa kita design macam ni? If we have 20 Newton meter, then you need to put 1 meter away from the center of gravity. If you have 10 Newton over here, then you need to put 2 meters away from the center of gravity. Sebab apa? Why? Because if you can see, when we talk about moment or torque is force times perpendicular distance. Force is 20 Newton times 1 meter. So it will be 20 Newton meter. Here, 10 meter times 2 meter. It also 20 Newton meter. This 10 Newton will rotate clockwise. This 20 Newton will rotate counterclockwise. The value of the torque is the same. 10 times 2, 20. 20 times 1, also 20. So it will balance. So the crate, the box of 20 Newton meter and 10 Newton meter will remain balanced because the torque value is the same for the right hand side and also for the left hand side. Sama. Faham? Faham Okay. Lagi. Okay, what is the weight? Ini yang kita cakap tadi, yang saya bagi tahu tadi. Weight is the attractive force that the earth exerts on the body. Okay. Weight is MA. Same thing as force. Force equals to MA. M is the mass. A is the gravitational acceleration. Okay. So weight equals to MA, or the same thing as mass. Force also equals to MA. Or sometimes we can see that weight W equals to mg. G is the gravitational acceleration. Sama weight sama dengan equals to MA. Weight equal to mg is the same thing. G is the gravitational acceleration. A also is the gravitational acceleration. The value of A, the value of G, you need to put 9.81. Not only 9.8, but everybody need to put 9.81. Kena sama Semua kena sama, 9.81. Okay, ada soalan? Ada soalan setakat ni? Ada tak? Ada soalan ke?
Tak ada.
Muhammad Ikhwan tak ada? Ahmad Ikhwan?
Tak ada.
Okey, faham Okey, sama. So, weight, the unit is in force. Sama. And then, what is pressure? Pressure, there are two terms for pressure. One is force per unit of area. The second definition of pressure is when you have a lot of Simon, then you have your own pressure. So that is the different thing. But now in biomechanics, pressure is force per unit area. Okay, pressure, sometimes we can put it as P, Okay, P, pressure. From the definitions, pressure is force per unit area. Okay, so P is pressure, F is the force, A is the area. The unit is in Newton for the force. Area is meter square. So Newton per meter square. That is for pressure. Okay. Kita tengok yang ni. Why would it hurt more to be stepped on by someone in high heels as compared to the same person wearing athletic shoes? So why? Sebab apa sakit kalau kita kena pijak dengan orang yang pakai high heel berbanding dengan orang yang pakai kasut sukan, for example. Why? Okay, this is related to pressure. Okay, this is related to pressure. Okay, and then another examples. Is it better to be stepped on by a woman wearing a spiked heel or by the same woman wearing a smooth sole court shoe? Okay, if a woman weight is 556 Newton, so that is the weight of the woman. The surface area of the spiked heel is 4 centimeters square, and the surface area of the court shoe is 175 centimeters square. How much pressure is exerted by each shoe? We have two types of shoe right now. One is the spike heel, tumit tinggi tu and then the other one is smooth sole court shoe, the flat surface. So which one? Okay, which one will hurt more? Okay, from here you can see that if you use the pressure formula, force equals to force divided by A. So we can differentiate between spike heel and also court shoe. So for spike heel, the weight of the woman, this is the weight of the woman, 556 Newton. The area of the spike here, the below area, okay, the below surface area is 4 centimeters square. So the pressure is 139 Newton per centimeter square. All right. If we use court shoe, the surface area is more bigger. The area is more bigger. So 175 centimeters square. The same weight divided by the area, you will get 3.18 Newton per centimeter square. So which one will hurt more if we try both shoe? So the answer is spike heel. Why? Yes, bagus Umil Natasha. Why? Sebab pressure dia 139. Tapi untuk court shoe, pressure only 3.18. So this is proven from the equations. So not just by logic thinking, spike heel will have more pressure, but by using the mathematical equation, still we can prove that by wearing spike heel, that person will hurt more on his body, or if he hits someone, then that person will hurt more if the person is using the spike heel shoe. Okay, kita tengok lagi, ada lagi tak contoh? Okay, stress. Now is stress. Okay, what is stress? Stress sama Stress is the same. Force per unit of area. Okay, this is stress. But the symbol of stress is not similar to pressure. This is symbol of stress. Stress equal to force per unit area. Pressure also equals to force divided by area. Okay, the same thing, the same equations, but the symbol is not the same. This is stress, this is pressure. The unit is also the same, Newton over meter square, Newton over meter square. So the distribution, if you can see from the left hand side and the right hand side, is not similar. So that is different distribution of stress. So the area play the main role on calculating the stress value and also the pressure value. Okay, we go to the next examples. Okay, the next example. Also by using the same concept of heel, of shoes. Okay, 85 kilogram woman stand on a vinyl floor wearing stiletto high heel shoes. If the heel has the dimension shown in diagram, I think in diagram, determine the average normal stress he exert on the floor and compare it with the average normal stress developed when a man having the same weight is wearing flat heel shoes. So we have woman, we have man. Woman wearing a stiletto high heel. A man is wearing flat heel shoes. Assume the entire weight is supported only by the heel of the one shoe. The mass is similar, 85 kilogram. But they wear different type of shoes. Okay, they wear different type of shoes. Okay, this is the woman wearing it. This is the man shoes. Okay, the weight, not the weight, the mass both is 85 kilogram. Can you help me? Okay, now, without looking to the notes, just by your understanding on my lecture, can you calculate the stress for both condition? Stress equal to force divided by area. Make sure you convert millimeters into meter. Convert first, millimeter into meters, then find the area of both conditions, then force divided by area. Boleh tak kita try? 2-3 minit je. Without looking to the notes, try on your own. Salah tak apa. So which one is better? Wearing high heel or wearing a flat shoe? In terms of stress, not in terms of pressure. Now we are talking in terms of stress. Okay, don't look at the don't look at the slide, yeah? Not the answer, sorry. Don't look at the answer. Try on your own, then we compare it. How do you calculate the area of these two types of shoe? If the calculation of error is wrong, then everything will be wrong, eh? So how to calculate the area? We have semicircle. Circle is pi r square. Betul kan? Pi r kuasa 2. Eh? So semicircle, pi r square divided by 2. Kirtana, okay? Okay, saya bagi 5 minit. You try dulu, eh? Okay, yang lain yang belum buka kamera, buka lah. Saya boleh kenal kat sini. Saya buka kamera saya, takkan you tak nak buka kamera you. Orang cakap apa, tak kenal maka tak cinta. Ha. Okay, can you do it, class? Come on. This is very straight way. Sometimes in your test or in your final exams, so I just giving you some situations, then you need to design your own condition for that two types of shoes, for example. Yeah, if I want you to design one shoes that is comfortable for men and women, what is the parameters that you will consider, for example? So you need to describe all the condition that will be considered to design that shoe. And you need also to put some example or some calculations that prove your concepts. So that will be also some sort of question that will be asked, yeah, on your exams or on your quizzes or on your tests. So please make sure you understand the concept well, so that it will help you to understand that type of questions. Kena faham konsep, eh? So don't just remember or don't just memorize the equation, but you also need to understand why we use that equations. Okay. Dah dapat jawapan? Okay dah ke? Okay ke? Mana habis ni suara?
Okay, doktor.
Saya dengar daripada tadi Ahmad Ikhwan, Muhammad Syafar. Okay ke? Mana suara Muhammad Syafar? Orangnya saya nampak. Okay. So, alright, saya move on, eh? Okay, first we need to calculate the area. So pi r square divided by 2 for the semicircular area. And then you need to add the area of the rectangular part. So you will get 1 to 5.86 millimeters square. But as I said to you just now, please convert it earlier from millimeters to meter. Because lastly, so you can see from the last equations, we will convert it into megapascal. Megapascal is in SI unit. So it will be like Newton per meter square. Okay, so Newton per meter square is Pascal. Newton, saya ulang, I repeat again, Newton per meter square equals to Pascal. Pascal, basically, on stress, when we deal with stress, the unit is Newton per meter square, or sometimes we use Pascal. Okay, why we have megapascal over here? Because it is 6.625 times 10 power of 6 Pascal. 10 kuasa 6 Pascal. So that's why we have megapascal. Mega is 10 power of 6, yeah? So make sure you convert earlier. This is in millimeter. This is also in millimeter. Then you will straight away get Newton per meter square at the end of the solutions. Okay, so when we compare high heel, stiletto high heels, and also flat shoes, the stress value is much higher on the stiletto shoes. 6.625 megapascal. For flat shoes, we only have 385 kilopascal. Kilo only. This is mega. This is only kilo. So the stress on stiletto high heel shoes is more higher than flat shoes. Okay? Boleh ke ini? Semua boleh ke?
Boleh,
Boleh,
Doktor.
Doktor.
Boleh, Doktor.
Okay, alhamdulillah. Boleh, alhamdulillah. Okay, then we move to the next term. What is volume? Volume is a space occupied by a body. Ada 3 dimensions. It has 3 dimensions: width, height, and also depth. The units are in millimeter. Millimeter? Millimeter apa? Millimeter square.
Cube.
Millimeter cube. The SI unit should be in millimeters, but sometimes the book put centimeter cube, and sometimes the question need you to convert centimeter cube into millimeter cubes. So Google how to convert centimeter cube into millimeter cube. How to convert millimeter square into meter square. So all those things you need to know, okay? Kena tahu because in the question somehow the question didn't give you any SI unit. The value is not in SI unit. So you need to convert that unit into SI unit. Then we have density. What is density? Density is mass per unit of volume, represented with the letter of rho. Rho macam huruf P, like the small p, but we call it rho. So rho is density. The units are in kg per meter cube. Okay, mass per volume. And we have specific weight represented by gamma. Okay, weight per unit of volume. Or some sort of examples that relate to density, mass, you can read it. And then we have impulse. You learn it in engineering mechanics. Impulse is the product of a force and the time over which the force acts. So J equals to Ft. J is impulse, F is the force, T is the time. I'm not covering impulse in biomechanics. Just want to let you know what is impulse. Okay, another symbol formula that we have in engineering mechanics and also some in biomechanics. So the unit, metric unit, SI unit, so you can see from the tables. Then, berapa dah? 8.46. Okay, what is compression? When we press or when we squeeze, force directed through a body, okay, then we call it compression. So if I have something over here, I press it, or I squeeze that things, then we call it compress. Okay, compression, yeah. What is tension? Tension is pulling. So pull away. This is like if I have some box over here and then I pull away, okay, saya tarik, or I stretch that things, then we call it tension. So from the figure also you can see that the left hand side is the original shapes. So when we have two pulling force or two stretching force, opposite directions, then we call it tension, yeah. And then what is shear? Okay, you can see also here from the black background figure, okay, shear, yeah. So you can see that the surface is moving downward. So that is shear. When two parallel surface touch each other, then we call it shear. Nampak dekat gambar tu So we have two surface, then one surface going down, then we will have shear force over there, and it also has shear area over there. Okay, nampak? That is shear. Then what is bending? So again, from that figure also you can see what is bending actually. You have two support reaction, and then you have one force in the middle pressing the beam, then it will bend. Dia akan bengkok. So that is bending. You have two support reaction and one other force in opposite direction. We call it as bending. And then you also have torsion. What is torsion? So load producing twisting of a body around its longitudinal axis. So if we have a bar or something and we twist that that object for both ends, then we call it torsion. Okay, kilasan Bila kita kilas, or when we twist that object in different directions, then we call it as torsion. Okay, what is deformation? Deformation is change in shape. So for the first region, you dah belajar ni dalam biomaterial you have learned it in biomaterial. So here, this is the first region. So the straight line is, this is a straight line, is the elastic region. Then after the yield point, we go to plastic region. Okay. Vector, you also learn about vector. What is vector? If I have this arrow, the first arrow, and then I add up the second arrow, then the length will be more. So twice, Same thing if I have this type of arrow, let's say this is 1, and then I add up with 2, and the final will be 3, because the direction is the same. Similar to this, also this vector. So if we add the vectors, then the length will be increasing. Okay, same here. This is small, this is much bigger. When you add these two vectors, then you'll get the small one, Okay, this is like a resultant vector. So when we have two different direction of vectors, one is to this side, one to the other side, then you just straight away draw another arrow, the purple arrow over here. This is the resultant vector. Okay, resultant vector, Okay, all the purple color. So you need to connect from the starting point here until the end of the two arrow. So we start it from here to here. This is our starting vector, the tail of the first arrow. Then we go to the last point of that arrow. Okay, vector resolution. Okay, okay, all right. So now we move to the next example that relate to vectors. Okay. If the resultant force of the two tugboats, boat tarik, is 3 kilonewton, directed along the positive x-axis, determine the required magnitude of force FB and its direction theta. So we have two tugboat, boat A, boat B. Okay, nampak kat sini? Force that represent by tugboat A is 2 kilonewton. FA 2 kilonewton. But FB, we don't have any value here. The angle of boat A is 30 degree. The angle of force B is unknown. So the question wants us to find the force of FB and also the angle by boat B. So how do we do that? Macam mana kita nak buat? Okay, we need to draw the vectors. So we have FA. Kita ada FA kat sini. Okay, saya tunjuk kat sini Kita ada FA, we have FA. This is FA. Okay. And then we have FB. Okay, FA, FB. So our resultant force, nampak? This is our resultant force. Pun tak nampak juga color dia kan? Okay. So it states that resultant force is 3 kilonewton. So this is 3. FA is 2. FA is 2. This is FB. So this is the value that the unknown that we want to find. So can you put that angles? How do you put that angles? Sorry, my line, this is not the actual line. The actual line should be straight. Okay, this is 3. Why it is straight? Because it say that, okay, it state that here, resultant force directed along the positive x-axis, sepanjang x-axis. So this is x-axis, x-axis. So it will lies on x-axis. Okay. So the angle is here is 30 degree. So from this triangle, can we calculate FB? Remember class, you have two law or two equation that you can use. One is cosine law, the other one is sine law. Here we can use cosine law. Cosine law, okay ke? FB, okay, I will write down that equation. You can check it. FB. Basically, FB square equals to 2 square plus 3 square minus 2. 3 cos 30 degree. Or Saya tunjuk kat sini. If we have this type of triangle, A, B, C, this is theta C. Opposite of side C is theta C. Opposite of side A is theta A over here. So if you want to use cosine law, if you want to find C, C square equals to A square plus B square minus 2AB cos theta C. Theta C, Ingat lagi tak, kelas? Ingat lagi ke? So this is how you use cosine law. Now, from this triangle, you can just substitute all the value that we know into that equation, then you will get the value of FB, So the value of FB now is 1615 kilonewton. Okay, boleh ke? Boleh ke?
Boleh
Ya.
kata.
Kalau tak faham kena beritahu And then how to find the angles? How to find these angles? Theta. So this is our original figure. Okay, this one. So that theta here is similar to that theta. So zigzag, Zigzag. Okay, if let's say, okay, I delete it first. Okay, the original figure, FA, and then we have FB. Okay, this is our resultant, this low line. Okay. This angle similar to this angle. It's similar, Zigzag, Similar. So by using cosine law, cosine law dia lain pula. Cosine law, okay, this is cosine law. This is A, B, C. So this is theta A. This is theta B. This is theta C. The opposite side is this is if this is C, opposite side is theta C. So cosine law, sine theta C over C equals to sine theta A equals to A, or sine theta B equals to B. This is sine law. That's why here we have sine theta. Okay, look at this figure, second figure. Sine theta equals to 2 kilonewton. Opposite side is 2. Sine 30 degree divided by FB. Okay, FB is 1.61. So you'll get theta equals to 38.3. Okay ke?
Okay, betul.
Okay, So this is how you solve these questions. Tengok dulu kalau ada yang tak faham. So see it first. If you miss something over there, okay, kita pergi yang seterusnya. Determine the magnitude of the resultant force Fr equals to F1 plus F2 and its direction. Okay, so how do we solve this one? The unit is in pound, eh? So just forget the unit. We assume it as F1 equals to 250 Newton. F2 is 375 Newton. So macam mana nak buat? Macam mana kita nak buat? Macam mana kita nak buat? So you need to draw another figure that represent the vector. So we have F1, F2, and then you need to draw the parallel shapes. Okay. Nampak eh? F1 over here. This is F1 eh? You need to draw another line here that parallel to F1. And you need to draw parallel line of F2. Then you will get this shape and then just connect the last line, eh? The resultant force. So from that resultant force, again, you need to put all the value over here. This is 75. Sebab apa dekat sini 75? How can we get 75 degree over here? Macam mana dapat 75 ni? How? Why we have 75 degree over here? If you cannot find this angle, 75 degree, then you cannot solve these questions. My question now, how do we get 75 degree? Macam mana kita dapat? Macam mana kita dapat? Okay, this is the original figure. I will show you the original figure. Okay. And then we draw back again. Okay, we put our resultant force. But my question now, why that angle is 75? Sebab apa 75? How do we get that one? Macam mana dapat eh? Macam mana dapat? Saya lukis balik, boleh? Kita tengok, saya lukis balik eh. Sekejap. Orang dah pening lah ni. Kita tak boleh lama-lama ni. Okay, kita buat balik. Saya tunjuk eh. So we have, kita tengok gambar dia sekejap. So I have F1. This is my F1. And then I have F2. Okay. And then I have X-axis. Okay, jangan tidur lagi ya. Sekejap lagi. Tidur pula. Okay, seterusnya. I just draw another parallel line of F1 and parallel line of F2. Okay, then my resultant force. Okay, this is my resultant force, Fr. Previously, we have, this is y-axis. I'll draw back. This is 30 degree. This is 45. Okay, that is 45. Okay, this is 30 degree. This is from the question, yeah? This is 45. So the remaining will be 45 because 90 degree, yeah? This is also 45. Okay. So my question now, how do we get this angle 75? This is not given in the questions, but we need to find it on our own. So how do we get that one? Okay. If I extend my arrow here, F2, okay, if I extend it here, okay, I draw another line here. Okay, and then I draw y-axis over here. Okay, we forget first. Okay, don't put first that 75. You assume that we do not know that value. So how to find that value? Okay, this is my y-axis. Okay, this is 45, betul tak? This is 45 kan? Sama tak? Ini pun 45, betul tak? Zigzag eh? This is 45, this is 45, correct? How about this one? Ini sama tak dengan ini? 30 degree here, sama kan?
Sama Doktor.
Okay, 30 degree. So total angle here will be 75. So 45 plus 30 degree, yeah? So from this triangle, you can use cosine law. F2, you know the value. Fr, we need to find. F1, we know the value. The angle of opposite side of Fr, we know that 75. So you will easily find the resultant value by using cosine law. Okay. Boleh ke?
Boleh
Boleh
Doktor.
Doktor.
Saya risau ni. Bila main part calculation, saya risau. Boleh ke? Saya laju ke? Is there any part that you do not understand? Okay,
Doktor,
Yes, Zunaira.
yang 30 degree tu dia parallel dengan line yang mana?
Okay, ni x-axis. This is y-axis, betul? Okay, this is also y-axis. Saya buat y-axis, sama. Ini F1 ni, ini line parallel to F1. So sama kalau kita tengok ini dengan ini sama, same. So when we draw back again, okay, saya tunjuk kat sini ya. Okay, this is my y-axis. I have this force. Okay. At the same time, this is my y-axis juga, my imaginary y-axis, and I have parallel line of this arrow. So this angle will be the same as this angle. Similar to this case. Okay ke Zunaira?
Okey. Faham Doktor. Terima kasih.
Alright, okay. So the rest, do you have any more questions before I end the class? Ada soalan tak?
Doktor, kalau force lebih daripada 3 macam mana Doktor?
Sekali lagi,
Kalau force lebih daripada 3.
yang tu kita kena lukis. That will be another diagram lah. Ikuan That will be another diagram. Maybe I'll try to find another problems that have 3 more forces. So let's say we have F1 over here, F2, F3, then you need to draw resultant force like that. So that's the another case. 2, 3, 4 forces, that will be another cases. If I can find the question that relate to your question just now, I will share maybe later on. Okay, ikuan
Okey Doktor.
Okay, yang tu different case. Okay, for this type of question, ada soalan lagi tak yang tak faham? No? Saya dengar tadi ada satu lagi soalan tadi. Siapa?
Oh, Doktor, tapi soalan saya bukan berkaitan dengan soalan tu. Nanti video ni boleh tak Doktor post dekat Google Classroom?
Boleh. Saya cakap hari tu tak ada siapa tanya dalam group. Okay, sure.
Okay,
I will share everything from my first lecture. Okay, Izzati Akmal.
Yeah, thank you Doktor.
Okay, welcome. Okay, ada soalan lagi? Any more questions, class? Sebelum saya habiskan sesi untuk hari ini. Tak ada? Next week, kita still ada satu kelas on Friday before we have a long holiday. But next week, lelaki kita pakai baju Melayu. Okay, perempuan pun boleh pakai baju kurung. Kita ambil gambar sikit next week. We take some photo before raya. Okay, so
Okay,
any other question?
Boleh Doktor, boleh.
Alright, cantik, same point. Ada soalan lagi?
So far, no, Doctor.
Tak ada saya tu.
So far, no, you know, If there is no more questions, then I think I'll stop it here. Then I'll see you again next week on same time and same sessions over here. Okay, thank you very much, class. Oh, okay, before that, your attendance. Before that, sebentar.